Okay, so we're taking a look today at density. So this is page 2 of our packet. And remember our density triangle. So we're going to draw a triangle. Okay, we're going to put a T in our triangle. And then above the T, we're going to put our M for mass. Sometimes we might call this the weight. We kind of interchange those. The density on the bottom left, and then the volume on the right. So if we're looking for the mass, right, we're going to do density times volume here. Okay. If I'm looking for the density, I'm going to cover that up, and I'm going to do mass divided by volume. Okay. And if I'm looking for the volume, then I'm going to do the mass divided by the density. All right, so you're just going to use this to figure out which one you're going to be working with. So number one's pretty simple. We're going to do the piece of wood. The mass and volume are given. So remember, we're looking for the density. So we're going to do the mass over the volume, and then I just plug in. So the mass is 25 grams over the volume, which is 29.4 centimeters cubed. And so this is our density. This does come out to about 0.85 grams per cubic centimeter. So every cubic centimeter volume, this would weigh, for this piece of wood, would weigh 0.85 grams. Number two, a little different than number one. They don't actually give us the mass, or they do. They don't actually give us the volume. We have to go calculate it. So this piece of wood, we want to know what's the density and then would it float. To be would it float, it does if it's under a density of 1 gram per cubic centimeter. So we'll take a look at this. So our volume is going to be length times width times height for this prism. Okay, so it's 3 centimeters times 6 centimeters times 4 centimeters. So this comes out to be 72 cubic centimeters for the volume. And then we want to know the density. So remember our triangle, mass, density, volume. So we're doing the mass over the volume. All right, so the density is equal to 80 divided by 72, and this is grams per centimeter cubed. And so this comes out to be 1.1 repeating, so it will not float. Okay, density is greater than 1. All right. Okay, for number 3, we have a square metal plate, has a density, and it has a weight. We want to know the volume. So remember, we're going to use our triangle here. So we want to know the volume of the plate, so we're going to do the mass divided by the density. So essentially just the mass of the weight over the density. So the volume is equal to 2.193 kilograms. Oh, and there's a problem right there. Grams and kilograms. So I'm going to have to actually go and convert this first. So I'm going to convert the kilograms into grams. So 2.193 kilograms. And remember, we're going from a bigger unit to a smaller unit. I'm going to move the decimal to the right. Okay, so I'm going to multiply times 1,000 here. So times 1,000. So I move my decimal point 3 spots over to the right, and this is actually equal to 2,193 grams. So my volume is equal to 2,193 grams divided by 10.2 grams per centimeter cubed. And this volume is going to be in cubic centimeters. So I just do, grab my calculator, hold it. Okay, so we're doing 2,193. So take our calculator, 2,193 divided by 10.2, right? And we get 215 cubic centimeters. So the volume is equal to 215 centimeters cubed, and there is our volume. All right. The base of this plate has an area of 25 centimeters squared. So remember, it's a square metal plate. Okay. So the volume is equal to the capital B times H. And this essentially is its thickness, is essentially the height here, how thick it is. All right. So the volume is 215 centimeters cubed. All right, we'll just put 215 in here. We won't put the centimeters cubed. We're going to divide it by centimeters squared. So we're going to get left with centimeters. And this is equal to 25 times h. So I'm just going to divide out by 25. So we're going to do 215 over 25. And I get 43 over 5, which is also the same as, so we'll do control divide, unit decimal, and that's 8.6. And this is just in centimeters. So remember, this would be centimeters cubed over centimeters squared. So these squared cancels out with basically 2 of this cubed and leaves us with just centimeters. So our units is just going to be in centimeters. Number 4, we did this one in class, but we'll walk through it again. So I have 500 bricks, or I want to purchase 500 bricks. The dimensions of the bricks are given in centimeters. We talked about that problem. The density is given in kilograms and meters cubed. And I want to know if my trailer can hold 900 kilograms, can I hold the weight of the 500 bricks? So we notice that we're in the wrong units. We want to be in meters and we're in centimeters. So I have to divide by 100 to figure out what this becomes. So we're going to convert 5.1 and we're going to get 0.051 meters. Same thing for 10.2 is 0.102 meters. And then when we move this over, we get 0.203, and this is also in meters. All right, so first thing we're going to do is we want to know the weight of our bricks, and then we're going to times it by 500. So remember our chart. I want to know the weight, which is essentially the mass. So I'm going to do density times volume. Okay, so the mass is equal to density, which is 1,920, times whatever we get for the volume. So the volume is length times width times height. So 0.102 times 0.051 times 203, not 023, 203. And this comes out to be a very fun decimal. This is 0.00105. 6006. Isn't it nice, isn't it? Meters cubed. So I'm going to plug that number in here, 0.00105, 6006, and multiply it times 1,920. This comes out to be 2.02, just about there, but we'll throw some numbers on. 753,152, and this is for one brick. So we multiply times 500, and we end up with 1,013.76576, and this is pounds, or no, not pounds, kilograms. All right, and so this is the weight of 500 bricks. And so we would say that he cannot, the trailer cannot hold and the reason is it's over 900 kilograms. Okay. All right. Number 5, we have a shipping container in the shape of a right rectangular prism with a length of 12, a width of 8.5, and a height of 4, and this is in feet. And what I want to pay attention to is the weight is given in pounds per cubic foot. So this is nice and easy. I don't have to do any conversions. I already have feet and cubic feet, so this is just volume. So we want to figure out what is the weight in pounds of the contents. So remember, that is a density question. So mass, density, volume. So we're going to do density times volume. All right, we have the density is 0.25 pounds per cubic foot. Now we have to calculate the volume. So the volume, remember, is length times width times height. So this is going to be 8.5 times 4 times 12, and our volume is 408 cubic feet. And so the weight, or the mass here, I don't want to write it, all right, is the density times the volume. So this is 0.25 pounds per cubic foot times 408 cubic feet. And so the mass is 102 pounds. All right. Okay, on the next page, we have something called population density. So population density is basically just the amount of people per square foot or acre or whatever we want to talk about here. So all we're going to do is take the population and then just divide it by the area. That's it. So for number 6, population density, living organisms to the amount of space. So in 2009, there were 6,342 penguins. So 6,342 penguins. And we want to get the density. So this is the number of penguins, and we're going to divide it by 47 to get per square acre. They could ask us for feet here, so we'd have to do a conversion and divide out, but they don't. So just divided by 47 gives me just about to the nearest whole number. This is 134.9. Okay, doesn't matter the rest of the numbers. So this is just about 135 penguins. Penguins, that's French for penguins, by the way, per acre. All right. Number 7, we want to know which state is more densely populated. So we're going to take the population, which is 19,795,791, divided by 47,126 square miles. Here we're going to take 20,271,272 and divide it by 53,625, and we're just going to compare them. So that's it. So the first one, we get approximately 420.06 people per square mile, okay? And for the second one, we take 20,271,272 divided by 53,625, and we are getting, remember, control enter on that, this is 378, essentially 0.02. So we would say that New York is more densely populated. Densely. Is there a word? Well, I'll put it for a word now. It's up there. Per square mile. All right. Number 8, in 2011, there were 3,223 sea otters. The bay is approximately, so to the nearest whole number, what is the sea population? So just the same thing, 3,223 over 77, and this is the amount of sea otters per square mile. So 3,233 divided by 77, and this is going to give us 41.857 and change. So this is approximately 42 sea otters per square mile. All right, number 9, in the 2010 U.S. Census, populations are given. They said which of the states has areas in square miles from largest to smallest. So they're giving us the population density and the population here. So remember that the population density, right, is equal to the population divided by the area. So if we solve here, right, we would get that the area is equal to the population divided by the population density. We're going to switch the area and population density around. So all I have to do is basically use that formula here, population divided by the density, and that'll give me the area. So for Florida, that's 18,801,310 divided by 350.6. For Illinois, 12,830,632 divided by 231.1. Okay. For New York, that's 19,378,102 divided by 411.2. And for Pennsylvania, we got ourselves, and these should be 12,702,379 divided by 283.9. So, bust out your calculators. And we end up with, for the first one, 53,600 and, well, it doesn't say what to round to, so we'll do 626.1. For Illinois, we're at 55,519.8 for New York, and you guys get the idea here. So let's see if we can just, and so we finished off with New York is 47,125.7 square miles, and Pennsylvania is 44,742. So the order, right, from largest to smallest is going to be Illinois, followed by Florida, New York, and then Pennsylvania. And that's our 1, 2, 3, and 4. Okay, that's it, guys. Tomorrow we'll finish up the back page, bring it back with you guys. Have a great day, guys. I'll see you later.